Okay, so we're going to talk about oxidation and reduction, or redox. Okay, so we probably familiar with both of these from GCSE. You know, the old definition of oxidation was adding oxygen, and reduction is removing oxygen. Just a very quick word. Why do we use this word reduction? Where does that come from? Well, it's a historic thing. Originally, it comes from dealing with extracting metals. So this is iron ore. Okay, so people iron ore. People didn't realize that it is iron oxide. Okay, and you heat that up with carbon, with coke, or with charcoal, and you would get a smaller amount of iron. Okay, so the amount was reduced. That's where the word comes from. And of course, we know what were we doing here. Why do we get less iron than the iron oxide? Because we have this is just iron here. There's no oxygen in it, so it's obviously going to be lighter. So that's where the word reduce comes from. Not always used to think, why don't they just call it deoxidation instead of this stupid word reduction? But that's where it comes from. Okay, and we are stuck with it. All right. Okay, so as I say, GCSE, you know the new definition of losing oxidation is losing electrons, reduction gaining, and you probably use the acronym OILRIG. Oxidation is loss, reduction is gain. So remember that. Just before we start strictly the A-level stuff, let's just make sure that there's no contradiction between these two different definitions. Okay, one is just a broader definition than the other. Let's have a think about magnesium. Okay, so if you get magnesium and you react it with oxygen, you are going to get magnesium oxide. So quite clearly in the old definition, yeah, the Mg is oxidized there because it's gained oxygen. Let's just look in the new definition. Well, what's happened to the magnesium? Well, the magnesium here is 282, isn't it? And it loses 2 electrons when it forms magnesium oxide, form Mg2+. So in the new definition, Mg is lost 2 electrons, so it's oxidized. And we can expand on that. Let's see what's happened to the oxygen. So the oxygen is 2,6, isn't it? I know it's in an oxygen molecule, but what's going to happen to that? It's going to gain electrons to form the oxide ion. Okay, so the oxygen has gained electrons, and so that's been reduced. And that's quite important here with this new definition. When something gets oxidized, something else must get reduced. If something's losing electrons, something else is gaining electrons. Okay, so that is the that is just a bit of a recap of GCSE stuff there. Let's just have a look at a reaction. Okay, again, this will be very familiar probably from year 9. A metal displacement reaction. You've probably known about this reaction for ages. Right, we get copper sulfate in aqueous solution, and you add zinc metal to it. Well, what's going to happen? You get a displacement reaction. You get copper metal, so it goes reddy brown on the surface of the zinc, and the blue color of the copper sulfate fades, and you get zinc sulfate in solution. Okay, so in year 9, you probably said something like, oh, the zinc's more reactive than the copper, so it takes the sulfate off the copper sulfate, which is like, you probably said that, and it's a good way of explaining it, but it's not really true at all, as we'll see. Let's just break this down into an ionic equation. Okay, so break this down into an ionic equation. So copper sulfate is made up of Cu2+ ions and sulfate ions, and of course, when you have an ionic solid dissolved in water, the ions are completely separate from each other. And we've got zinc there. And on this side, the copper has gone to the copper element. And zinc sulfate in aqueous solution, so that's going to be Zn2+ ions and SO4 2- ions. So we can get rid of the spectator ions there. things that don't change on either side of the equation, which is obviously going to be the sulfate. Get rid of that. So we can now see the wood for the trees, if you like, and we see really what's happening here. Well, copper has gone from T to there. So what's happened to it? It's gained 2 electrons, isn't it, to do that? And the zinc, well, that has gone from Zn to Zn2 plus, that's lost 2 electrons. So what we can do is we can break this down into 2 half equations. Now, half equations, you probably have, you have come across them before, particularly when you're dealing with electrolysis. And at GCSE, people generally speaking don't like half equations. And maybe one of the things you remember about them, they always have got electrons in them. So that's how you can spot a half equation. So let's see what's happening to Cu2 plus. Well, that's gaining, that's got to go to Cu, hasn't it? So what does it need? It needs 2 electrons. And the zinc, well, that's the other way around. The zinc is going to go to Zn2 plus. So that means it must have lost those 2 electrons there. So this 2 half equations here, we've broken down our full ionic equation into 2 half equations. We can see what's happening here, and we can see that how the electrons are actually being passed from the zinc. Those electrons there are going to go up to the copper there. Okay, and we can see that that metal displacement reaction is a redox reaction, and really it's nothing to do with the sulfate ion. It's a battle for electrons, isn't it? Who wants to lose electrons the most? And the zinc wants to lose them more because it's more reactive. Okay, so I think with that nice short video, just reminding us about oil rig and redox, and we'll leave it there. And the next video will have some A-level content. Really, that was just GCSE.